Welcome to another of my videos where I work through and explain A-level physics multi-choice questions. If you want to try this question yourself, pause the video now. If you came up with the answer B, give yourself a pat on the back. If you'd like to see my explanation of how I found the answer, please continue watching. So the diagram shows a string stretched between two fixed points O and R, which are 120 centimeters apart. P and Q are points on the string. O to P is 30 centimeters and O to Q is 90 centimeters. At a certain frequency, the string vibrates at its first harmonic. P and Q oscillate in phase. The frequency is gradually increased. What is the next harmonic at which P and Q will oscillate in phase? Well, we're going to produce a standing wave here because the points O and R are fixed. And if I look at a standing wave, let's draw a standing wave made of two wavelengths. There are points on the wave where the amplitude is always zero. These are called nodes. Between the nodes, all the points oscillate at the same frequency with each other, all in the same phase of their cycle. If we move one node on, all the points on the wave are oscillating at 180 degrees out of phase with this first section. If we go two nodes away from this first section, let's call that first section A, second section B, and the third section C. So if we go to C, which is the third half wavelength, then all the points in section C are again in phase with section A. So on a standing wave, a nice simple rule is, if areas on the wave are separated by an even number of nodes, in this case two nodes, they will oscillate in phase with each other. If they're separated by an odd number of nodes, in this case one, they will oscillate at 180 degrees out of phase with each other. So it says at a certain frequency the string vibrates at its first harmonic. Well, the first harmonic looks like that, and that's when the length of the string is equal to half a wavelength. You can see that is just half a wavelength. Well, P and Q are going to be oscillating in phase with each other, which we're told as well. P and Q oscillate in phase. The frequency is gradually increased. What is the next harmonic at which P and Q will oscillate in phase? Well, the next harmonic we'll get will be the second harmonic, and the second harmonic is when the length of the string is equal to the wavelength. And we can see P and Q are separated by one node. So the points P and Q will oscillate 180 degrees out of phase with each other. So it's not the second harmonic. The third harmonic occurs when the length of the string is equal to 1.5 wavelengths. And we can now see that P is separated from Q by 2 nodes. So P and Q will oscillate in phase with each other when the third harmonic occurs. I hope you found this useful. Please give a like and leave a comment below, and I hope you'll watch more in the series.